Hi, in this video, I'm going to give you a quick demonstration of how AmadeusBio.ai, a Cloud Code plugin that enables bioinformatic analysis, work. So you can access the plugin at site, you guessed it, AmadeusBio.ai, and it's gonna have the instruction to set up. So to set it up, you can just clone the minimal viable product version of AmadeusBio.ai from GitHub, and then you can execute the following command to run it in Cloud Code. If you want to use the PyMol feature, you will have to also configure your PyMol as well, um, so that you will start listening to Cloud Code. You can follow these steps, and I have a more detailed steps if you can go to the PyMol installations page on the website. To begin, you will create the directory that you want Cloud Code to start working. So here I named it AmadeusBio underscore demo. I'm going to cd to that directory, and I'm going to run the plugin command, which is here. I'm going to add an additional skip permission flag to this command so that the demo will run smoother, but do not include this flag if you are experimenting with new things. I'm going to run it, and now Claude is executing. So here, if you go to the agents window, we have two agents that are pre-configured in this plugin. We have a protein structure downloader agent and a PyMol software operator agent. So they are set up so that we can download the protein structure and operate them in PyMol. I'm gonna escape, and I'm gonna just write prompt here. Write prompt download all of the BBX proteins in Arabidopsis, and it hits here. So you're gonna keep thinking and burn some tokens, and meanwhile, I can show you the agents monitor web UI that I have built, and actually it's taken from open source, and I made some modifications. So if you go to sessions, you can see this session is active, and go to conversation, you can see that yes, indeed, I told Claude to download all of the BBX protein in Arabidopsis, and here is the Claude's respond, and then you can have a timeline of what Claude decided to do and what's currently running. And this monitoring tool also have other features that allow you to monitor your costs and other stuff, your daily usage. Yeah. So meanwhile, for literature search and all other functionality that doesn't have to be run locally, I will still recommend using the whatever your favorite LLM in the web browser version. So I'm using Gemini in this case since I have burned up all of my Claude Code quota today. So it's the same model that they're running, but the browser version is very good at web search, and the local version is more tuned to operate local files. And you can reinvent a wheel by using the local version to do web search, but it's just kind of why you're doing that when you can just use the browser version. I'm gonna ask Gemini to find the zinc binding residues in Arabidopsis BBX31. And meanwhile, Claude is still thinking, and it's probably thinking about how it should download the many protein structures from the BBX family. And as you can see here, all of the downloading process is run by the downloading subagent. So there are the main subagent here, the main agent here, which is supervising the subagent, and then the subagent running here. So you can see both prompts. You can see what the subagent is trying to do, and yeah. And now Gemini has got back to me. So it looks like the zinc binding residues are those four and those four. And that's interesting. And I will keep that in mind when running cloud code in the PyMol. It's still running, and just wait a little. And since we're downloading 30 plus protein structures, it's gonna take a little while to download. It has taken, so right now 6 minutes has passed and it seems like it's still downloading, so that just have patience. And meanwhile, you can use your browser as normal while cloud code kept running on your machines. So yeah, it just the time it takes to download. You'll probably also take similar amount of time if you were to batch download using AI. All right. So it says that all 32 Arabidopsis PBX protein were successfully downloaded, and I'm gonna check if it is truly downloaded by using the add structures. Um, and it seems like the naming convention is Arabidopsis slash BBX, and scroll through, see whether it has BBX 31. It looks like it does have BBX 31, which is great. And I'm gonna tell Claude to open this structure at the following at the following directory in PyMol, and here I'm gonna tell Cloudcode to make the zinc ion 1 coordinating residue blue. Make, I'm gonna use a little bit prompt engineering here, so I'm gonna put it in markdown format, blue, and make the next four residue red. Make those residue red. And I'm gonna see how cloud code react to the prompt. And it's asking what color should it be? It should be red, yes. Oh, cloud code has successfully opened up PyMol. Let's take a look here. You can see the BBX protein is now successfully loaded. And let's see how it makes the residues. I'm gonna make this window a little bit bigger. And here, ta-da! you can see indeed those residues are blue and those residues are red. And I'm really happy that the demo seems to be working. And let's just wait a little and see what Claude have other stuff it has to say. It seems like it's verifying. It's verifying that the residues are correct. Oh, um, looks like they have successfully made site 1 blue and site 2 red. And the whole process took 14 minutes, given that it's a demo. And thank you.